Hello, everyone. My name is Jorge, and I'm a software engineer at Grafana Labs. And as you can see, Manoj is not here with me today, but he's a VP of engineering in the observability department, also at Grafana Labs. Manoj basically has been traveling for the last 2 months, and he really wanted to spend the Diwali with his family. So it's going to be just me today. But let's get started. I want to talk about alerting and how you could make it more useful during your troubleshooting. But first of all, I wanted to know, raise your hand if you attended PromCon 2024 last year. All right, quite a few hands. And raise your hand if you have tried this anomaly detection framework from last year. Okay, quite a few. All right. So Manoj and I presented this framework last year at PromCon, which was basically a set of recording rules and alerting rules that will allow you to basically draw these bounds for your metrics and detect when they are like out of bounds and that there is an anomaly in your metric. And we also said in the talk that we thought that you shouldn't page on anomalies, and we actually got some questions about this and why that's the case and how should you use it then. And the first question that you should ask is like whether you should wake this guy up at night because there was an anomaly, because there was a change in the pattern in your metrics. And very likely the answer is no, because the anomaly detection system tells you that something is different, but not necessarily that something is wrong. And so the next thing that you might think is like, okay, let's just go and make it a warning. But if your Slack notification channel looks like mine, funny enough, I was preparing this slide, and I noticed that I had a completely muted mine, and I never look at it, right? So that would have been adding more noise to the mountain of noise that we have already there. And that's really the problem, right? When everything is important, at the end, nothing is important, but it's not useless, right? All of this is context, and that's kind of the key. We think that you should page on actionable symptoms, things like require immediate remediation, that you need an action. But everything else you can still use as context. And the question is, how can we visualize it and make it useful enough that we can actually make use of this? And that's what the whole talk is going to be all about. And this slide is really important. So I want to introduce here a new concept, and it's called an assertion. And an assertion is basically, I want you to think of it as, when you have a car and you're driving, you don't have a lot of time to look at complex data. So you probably want to have a very, abstracted view of the world that tells you that something needs attention, right? So in your car, you're driving, maybe you see that you need to go to the gas station, or maybe, you're low in oil, but you actually get this powerful visualization that tells you, okay, here is something that, requires your attention right now, and you can immediately process it. And that allows you to, have this view of the system. So an assertion, think of it as, an indicator light, something that bubbles up, that lights up, and that tells you that something requires your attention. And if we take a step back and we think about how we do incident response, right? So you typically get paged, and if you're like me, the first thing that you do is probably you jump to the dashboard that's related to the alert, and you try to analyze, okay, what happened? What are the symptoms? What's happening here? But most of the systems that we operate are complex systems. And usually what you're seeing is just a symptom of a cause that is probably happening elsewhere. And so what you do is usually try to go up, zoom out, and create a view of the world of your system, of what's happening in your system at the global level, and try to infer the cause out of the symptom. And there's another way that is complementary that you can actually look at this problem, and it's basically a top-down approach, where when you get paged, the first thing that you see is you go to the system overview, and hopefully the system overview is like abstracted away enough that it just gives you the light indicators that you need to see to know where to look and where to debug further. And from that system view, you can go to specific components, and then you try to create a hypothesis of what could be having the cause of this problem. And just this is an example dashboard that basically what I'm thinking about when I think about this, that is similar to the car metaphor, which is like a dashboard that tells you what's up with my system, right? Like tell me at the global level what's happening in my system. Is my system healthy? And here, for example, in this dashboard, you can see that there is some red. That's probably bad. There's some orange, maybe orange, doesn't require immediate attention, but probably I should be looking into it. And and blue, it's basically that something changed in my system. Obviously, if you're looking at your whole system, there's going to be a lot of stuff in there, and you probably want to have a way to measure what's important and where to look. And one way you can do that is you can actually take, for example, this list of jobs and score all these assertions that you're seeing by order of importance. And we will define what importance, how is it is defined in a minute. But the idea is that you can actually rank it, and then you can maybe take the top 5, top 10, and focus on those exclusively. And once you do that, once you do the filtering, then you can actually look at, I think, what's the most important visualization here, which is the assertions that fire over time together in a timeline for the jobs that you selected. So in the example here, there is a version rollout for a specific service that actually created a bunch of errors in other services, as well as like high CPU usage and an anomaly in my host. And this is really like something that can really help you understand the cause, what triggered the problem and what were the consequences of it. So from there on, then, as I said, you can jump to the specific component dashboard. For example, this is like a modified version of the OpenTelemetry demo dashboard. And I think what's interesting is that you can then look at your metrics, but you can also bring all these concept assertions to your dashboard. So you always have this high-level overview of like the events of interest in front of you. And I hope that I convinced you that this is interesting, and then that you're willing to go and look at some rules, recording rules and alerting rules with me. So obviously, there is nothing new here, right? Prometheus already have the concept of discrete event, and that's called an alert. And Prometheus already has a rule evaluation engine that is evaluating your alerts. And if your alerts, fire, then they will get pushed to Alert Manager, where they will get duplicated and then sent to the channels that you have configured. But there is another way of using alerts, and you can actually query alerts directly. So you have a metric in Prometheus called alerts, and you can set some conditions, for example, the alert state, and that way you can visualize over time, which alerts fire when over time. And an assertion, as I just defined, is actually an augmented alert that has 2 labels that we have predefined. One is the category, and the other one is the severity. And I will talk about each of them individually in a moment. But just think about an alert. An assertion is basically a specialized alert with some extra information. So at this point, I want to talk about SAAFE and what it means. So SAAFE stands for saturation, amend, anomaly, failure, and error. And it's a taxonomy for your alerts. So it's a way to classify your alerts, to attach some additional information to them so that they can be useful when you observe your system holistically. And I think it's important for 2 reasons. The first one is because it allows you to aggregate your alerts and see them like in aggregate, filter by them. But the other one is that it actually informs the kind of things that you should be measuring and bubbling up as assertions, because this system is only complete if you have a complete enough picture of the world. If you miss important things, then it was not that useful. So this model actually allows you, lets you think about the kind of things that you should be thinking about when thinking about, creating this kind of system overview. And let's start with the first one. The first S in SAAFE is saturation. And I'm oversimplifying here, but I'm just saying that a resource is being overutilized, right? You can think of CPU, memory, I/O, but it could also be something in your service. For example, the request queue is full, right? And if you have the metrics, then you can expose that. You can create alerts for it, and you can actually create an assertion. I'm giving the example here of high CPU usage. The metric itself is not too important, but basically what's saying is that if your CPU is or your machine has a CPU utilization above 80% for 10 minutes, then fire this alert. And then, as you can see, I'm attaching the extra labels I just mentioned. What's interesting here is the severity that assigned for the SAAFE model is not necessarily the same as the one that you use for paging. So you can keep these 2 things independent. This is just how we visualize them. And the other part is the category that I just mentioned is saturation. Now we have amend, and actually this is, to me, one of the most important ones, because most of the outages that happen in a system happen because something changed, right? Somebody changed something. And this is a way that you can actually keep track of what changed in your system and visualize it as an assertion. And it's not specific to your services, right? It could be service rollouts, it could be scaling events, it could be that scaling nodes in your Kubernetes cluster. Anything that implies a change can be modeled this way if you have a metric to represent it. And this is going to be a tricky one. I'm going to show you how you can create an assertion for every time that you roll out a service. And let's start from the beginning. I'm using target info here, but this works, as I said, for any metric that has a label that represents the version. So I'm taking this metric. It gives me all of the targets that are defined by target info. The first thing I do is I group them by job and service version. And this basically ends up with a series per unique combination of job and version, right? So you just get that, and you get a series with a value of 1. Then this is a little trick. What we're doing here, this is a Prometheus subquery. What we're doing is like creating a 5-minute window. So we're looking back 5 minutes, and we're sampling every minute. And in this 5-minute window, we're basically producing data points. So in this case, it will be 5 data points over 5 minutes because we're doing the sampling. And once you do that, you just count by job. And what you get in this recording rule is the number of versions that happened in the last 5 minutes. Okay, so this is the foundation. And once you have that, now you can do something like this. So I'm using Delta here, by the way. All these rules can be improved, I'm pretty sure. So feel free to talk to me or send a PR later if you have ideas how to improve them. But the alert here, basically what's doing is detecting if there has been a new version, an increase in the number of versions for your job, right? So if there is a new rollout in this 5-minute window, it's likely that you will have the 2 versions, and you will capture that as an assertion. And you can also see that there is no for key here. This fires immediately as soon as you detect that there was a new version happening. I'm assigning a severity of info, but as you can imagine, this is super important to detect the root cause. If you have really complete information about all your changes in your system, you will be able to make a lot of these assertions. And I think also what's interesting here is that we don't need an event, right, to see our rollouts. We can use alerts for that and visualize them. Okay, now we're Anomaly. So this is the third one. How are the energy levels, by the way? Too many rules so far? No? Okay. So as we can define it as an unexpected change in metric patterns. I just mentioned last year we gave a whole talk about this, and you can actually use this framework to detect anomalies. The way that you use this framework is basically you copy the recording rules to your Prometheus instance, and then every metric that you want to detect anomalies for, you basically just create a recording rule wrapping the metric. So for example, we're doing the request rate here by job. And the important part is that you assign a label called anomaly name. And as soon as this label is found, the framework will actually process it. And you will be able to see something like this, basically draw bounds around your metric and detect when it falls outside of the bounds. The main thing that we changed here since last year is that we actually generalized the framework. And now we support multiple strategies, and you can actually run them all side by side and compare which one worked best for you. And we introduced a new robust strategy that uses robust statistics. It might work better, for example, if you have non-normally distributed metrics, or if you want to capture trends that are, not just like spikes or changes, sudden changes in your metrics, but actually, slow changes. So we are planning to add more strategies here, but yeah, you can now run them all, try them, and then see what works best for you. And going back to the SAFE model, this framework comes with an alert that is defined as the one I saw you here. So if your metric goes above or below your bands for enough time, it will fire an anomaly assertion. In this case, we just made it a warning. Okay, failure. So 2 more to go. Failure, basically, I have defined as a violated invariant affecting your system integrity, but the short version of it is that you have an expectation for your system that is not being met. It's not happening, right? And an example is a critical job that should always be up is not up, it's down. But it could be that you have an insufficient number of replicas, or a pod is cross-looping. Basically, the system is not meeting your expected state and you detect that. And an easy example here is whether when an instance is down or unreachable. So here I'm showing an alert that if a specific instance is not reachable for more than in a 5-minute period for more than 20% of the time, then we will immediately fire a critical assertion and you will be able to visualize it. The important part here on failure is that this is a qualitative, it's like a yes or no, right? Either the system has integrity or it doesn't, and if it doesn't, you fire an alert. And that's different from the last one in the list, which is error. An error, you probably have a preconception of it. It's basically defined as an unfulfilled or degraded service response, but you can think of it as a high error rate or SLO breach. The important part here is that this is quantitative because no system is free of errors. And you define the tolerance, how many errors you are willing to tolerate with your SLOs. And that's how it differentiates. Error is above my level of tolerance for errors versus like failure where it's basically, the system has no integrity for some reason. And the easy one here is the error rate. Don't pay too much attention to the rule, but it's basically number of error requests divided by the total. If that's about 5%, you have more than 5% errors. That's a critical assertion, and you will just fire it. And if you put it all together, then you can get a very complete view of your system health, like just as a bird's eye view of your system before you even jump to anything else. Okay. So I want to say a few words about the scoring or ranking system that I mentioned and how this will work. How do we assign importance to a specific assertion? And I'm going to show you a heuristic here or an algorithm that you could use. So you could say that the score for an assertion is basically how long it's been firing for, each duration, times a specific weight that we're going to define. And expressed in PromQL, the duration can be measured as the count over time for a specific time window. For example, in 1 hour, how many data points are there for that specific alert? That gives you already a number that represents the duration. And then you multiply by the weight. And this I'm using a constant. And the important part is that it's based on the severity. So as an example, I'm defining 3 constants here using recording rules. And I'm saying that info and warning assertions have a weight of 1, and critical assertions have a weight of 2. And that's all really. With this, you have the safe model, the view, the ranking, and basically all of this that I mentioned here is open source. So you can go there, Grafana/safe model, play with it. There's some documentation again for the safe model itself, some example rules for each of the categories, some dashboards, and a demo that you can just run, make, start, and play with it. And I just want to, before I end the presentation, I want to say a few last words about how you could take it to the next level and how we're actually using all of this that I showed you. And we have a product that's called Knowledge Graph. It's been rebranded recently, but it's literally a combination of the safe model and an entity map. And an entity map is basically a way to extract a graph out of your system, and basically has entities and relations. An entity could be a service, could be an infrastructure node, a database, and a relation is like a relation between these 2 entities. For example, service A calls service B, service A calls database A, or it could also be that a service is running in a specific node in Kubernetes. And it's very likely that you already have these metrics that express relations. For example, if you use Istio, you probably already have relation metrics. If you use kubestate metrics, you probably have information about which workloads running which nodes. Or if you use OpenTelemetry service graph, you already have a relation between which services call it, which other services. So once you extract this, and by the way, this is actually produced just running PromQL queries. So you can run PromQL queries and extract the relations. And once you do that, the main advantage that you have is that then when I show you a view like the one I showed you before in the dashboard, you can pick a service and then you can pick all the connected entities for that service, because you're basically looking at everything that's related to that service and then show all the assertions over time in a timeline for all the related entities. That's really much it. We have a collection of predefined assertions, but the idea is that you bring your own because you know your alerts better than anyone else. That's all I had. I just want to thank the original authors. None of these ideas are mine. So Manoj and this gentleman here are the ones that came up with these ideas. And I'm happy to take any questions. And also you can feel free to go to the community channel for Grafana and ask there. And I just have a question before I take questions myself. If Bjorn is here, whether you think that this is observability or not. I would like to run your CAP model for this. All right, thank you very much.
No questions. Okay.
Hi. How do you decide what is worth making context? Like which assertions are worth setting up?
I think most of them actually, you can categorize them, right? Like if it's worth making an alert for it, you either want to pay someone or you want to bring it as context. So if that's not useful to you, then probably you shouldn't have an alert for it. But if it's worth making an alert, you probably want to visualize it.
So each alert should have assertions that make the context.
Yeah, you just think about, you take your alerts and you think about, okay, which category is this alert and which level of severity I want to assign to it. The idea is that you bubble up this and you can put it in a timeline. That's, yeah.
Thank you.
Any other questions? All right, then big round of applause again, please.